Talked about sets and we talked about maps and we talked about array functions in this course. We're going to wrap up this course by exploring typed arrays. Now, typed arrays is a very specific type of array and it is designed to handle direct memory allocation. So you can actually go in and store things inside of the memory and work with it that way, which helps being able to have your applications run faster. As web apps start to work more and more with large amounts of data, this might be useful as well. So we're going to go ahead and define what a typed array is. We're not going to dive too deep into typed arrays in this section, but we're at least going to explore what it is. We're going to explore how you can start using it and how you can go in and start manipulating the typed arrays as well. So let's go ahead and first of all just talk about what a typed array is. Before we start working with typed arrays, let's go in and let's define what typed arrays are. So typed arrays are array-like objects that provide a mechanism for accessing raw binary data. And you can get straight to this data, so you can actually work with this data quicker and easier. And if you have a web app or working with a web app that has to do with a lot of data, then typed arrays may be a good source for you. Let's talk about some of the benefits of using typed arrays. And the main benefit we've already talked about, but it bears repeating, is accessing raw binary data. You can get straight to that data. It then allows you to do faster performance and faster data manipulation as well. And it's strictly controlled data. So that means you can't put just any data inside of a typed array. It is controlled and it depends on what type of view that you're actually working with. And there are a lot of APIs that support typed arrays that you can use in order to get this faster performance and access to this raw binary data. So some of the APIs that you may need to use or you may want to use are things like WebGL, Canvas, Web Audio API, XML HTTP requests, Fetch API, WebSockets, Web Workers, Media Source API, and File APIs. A lot of different APIs available that will support typed arrays, and you can start using them right away. So the key to the typed array structure is being able to actually create an array buffer. When you create this array buffer, you defined how many bytes you actually want to work with inside of this array buffer. And you do that inside of your JavaScript file. The problem is, though, this JavaScript file cannot communicate directly to this array buffer. In order to communicate it and get the functionality of an array, you actually have to create what's called a view. Now that view can contain different types of data. So in this case, we have a uint8 array, or we have a uint16 array, uint32 array, float64 array, and there's other types. Depending on the type of view that you create, you'll have different sets of structures in there that contain different types of bytes there. The key is how many bytes you actually initially create. So if I created 16 bytes, then that means with an 8 array, that means I have 1 byte each. And so that means I can have 16 different sections starting out with 0 going all the way up to 15, and I can store data in there. Now, if it is going to be an int8 array, that means I can only actually use certain types of numbers. Now, if I'm going to do as int16, that means I have 2 bytes each, and that means I can only have 8. And so if I'm using 2 bytes, I only have 8 to work with, and I can't go beyond, and I can't place something in like the 9 section or anything like that. If I'm working with an int32 array, then I can work with higher numbers, but it's going to take up 4 bytes each, and that way I only have actually 4 spots to work with. If I'm going to do a float64, that gives me a greater amount of numbers, but it lessens the amount of spaces that I have to work with. So in this case, with only 16 bytes, I can only split that up into 2 different spots there. And then inside of my JavaScript, I actually communicate to these views. So I've defined what type of number I'm working with. I've also defined the spot that that number is going to be stored inside of my array. And then I do all of that inside of my JavaScript. So hopefully that helps you actually understand how to create the arrays and how to split up the arrays depending on the types of numbers that you're using. The key, though, is remembering that you're communicating to these different spots. And so if I wanted to place a number that's this 8 array here, then I would actually have to define what spot it's going to go in. It automatically creates those spots for me, and all of them start out as 0. But if I want to update a number in the second spot, then I would have to make sure that I update it in that spot, or I can update it in the 5th spot, or in this case, it's the 6th spot because it starts out at 0. What type of numbers can I place in each of these types of arrays? Well, that depends on the array that you're actually using. So these are the different types of arrays that I can create. So if I'm going to use an int8 array, Then I have from negative 128 to 127. If I try to place anything like 128 or anything above there, it won't happen. I'll run into some different errors there. Now, the size in bytes, if I stick within those numbers and within that array, is only 1 byte per section, essentially. So then I have uint, which gives me 0 to 255, uint 8 clamped, which means that if it goes above 255, I won't get that error, but it's just going to clamp it and keep it at 255 in case it does go beyond. That's maybe something as kind of a safety mechanism that you want to keep in there. Int 16, you have negative 32,768 to 32,767. So it just depends on what type of array that you actually want to use and the types of numbers that you're actually going to store in that array. And it goes all the way up to big unassigned integer 64 array. And you'll notice also the float 64 array if you're working with those numbers, but it does take up 8 bytes with each of these bigger numbers. So that's the concept. We're going to go ahead and start creating an array. We're going to create a buffer, and then we're going to go in and create some views in order to communicate to that. Now the view will then store that inside of that buffer, but I can't actually go into that buffer and manipulate anything about that buffer. I have to go into the view and manipulate the view, and then it will automatically manipulate and update the buffer from there. So that'll make a little bit more sense once we actually dive in and start working with these typed arrays. So one more thing that I wanted to cover before we dive in and start working with these arrays is what are typed arrays versus standard arrays? Why would I use typed arrays and why would I use standard arrays? And so let's compare the different two types of arrays. So in standard arrays, we accept pretty much any data type. We're able to use standard variable storage. We're also able to use standard processing as well and being able to iterate through it as well. With typed arrays, we're restricted on the data types. We only have certain numbers depending on what type of view array that you actually create. So if you do the unassigned integer 8 array, you have certain types of numbers that you have to stick with within that array. One of the benefits, though, is you have access to this binary data, is it becomes a lot faster to actually work with this type of array. And so if you're using a lot of data that's just numbers, well, then a typed array may be a very beneficial thing for you to do because it's just so much faster as far as the processing, being able to work with this. You have your APIs like the WebGL, you have the media APIs as well. So if you're doing a lot of that type of manipulation on really heavy coding there, then you may want to stick with that. Once it's in a view, it does act like an array. So you have all of the methods to an array and properties to an array, and so you can actually use it just like an array at that point. And then you get access to those native APIs. So WebGL, you have Canvas as well. So if you're working with those different types of APIs, you have access to that and you can take advantage of that and make it go quicker and perform quicker by using these typed arrays. So that's some of the differences between a standard array and a typed array. And in the next section, we're actually going to go in and build the buffer and show you how to build the buffer itself. And in the following section, we're going to go in and build the views and show you how to actually add data through the views. Let's first start out by creating this buffer. It's a pretty simple process to be able to create the buffer, but we need to be able to do that before we can start creating the views on top of that buffer and start adding the data. Keep in mind that we cannot manipulate the buffer itself. We have to create a view in order to do that. Download the sample project, and then we have this 01 starter project file. Make sure you download it for this section, and make sure that you save your project from the last section so you don't mess that up as well. And so I'm going to come into this 01 starter project file, and I'm going to copy that and paste it onto my desktop. Now, with that on my desktop, I'm going to go ahead and double click on this and then double click on the index.html. That's going to pull up my project here, and we're going to go in and open this project up inside of Sublime. So I have this project open up inside of Sublime. I'm going to go ahead and open up the index.html. And notice if I come back into my window here, I don't have all those different sections. I've kind of simplified it a little bit more because we're just going to be working with this binary data. Now I'm going to come in here and actually go into my page.js, and I've gotten rid of some of the different functions. I've gotten rid of the yearly total as well. We're mostly going to be working with the JavaScript inside of this section here. So now I'm going to go in and create my array buffer where it says code goes here. Let's go ahead and get rid of that, and let's say let test buffer this is just a test that we're going to be working with, equal new, and then we're going to say array buffer. So this is actually not an array, but this is an array buffer. Now we need to define the number of bytes that we're going to allow inside of this array buffer. I'm going to go ahead and say 16 because that's the examples that we've been working with. So we're going to go ahead and create that array buffer. That just defines inside of the memory that we have these 16 bytes that we can work with. So at this point, I can't really do much with it. We need to be able to create a view so I know what type of data is acceptable inside of this array. But we can check to see if the byte length is a certain number. So I could come in here and run an if statement here and say if test buffer dot length or byte length, we're looking for byte length exactly, so byte length is equal to 16, then we're going to say alert yes. That's really all that we're going to do. We're just going to test the byte length there. So if I come in here and hit preview, you'll notice that it says alert yes. So if you needed to do a quick, if you have a lot of different array buffers in here and you needed to do a quick check to see if this is the right byte length, then you can go ahead and do that as well. I'm going to get rid of that if statement there. And now in the next video, we're going to talk about actually creating a view on top of that array buffer. Now that we've created the buffer, we're going to go ahead and actually create the views so we can access the data and update the data. And there's different ways that we can actually do this. So I'm going into the code and we're going to explore a couple different ways. So let's just go ahead and create our data here. And I'm going to say let view1 equals, and we're going to say new int 8 array. This is how we define it as far as what type of integers are going to be placed inside of this buffer. We're going to say that this is going to be an int array, and we are going to go ahead and pass in test buffer. We have to pass in what our array buffer is, and that's how we know how many bytes we have to work with. Now that I have that, I'm going to go ahead and type in view1, and I'm going to choose the slot. You've just created 16 different slots inside of this array buffer, and now I want to go in and update the first one. So within these brackets, I'm going to say 0, and that will update the first one. And I can define it by saying 32. Now, keep in mind the different amounts that are available inside of my int 8. I believe it was negative 128 to 127. So I can't really go above that. So I'm going to go ahead and console.log this. And now I'm going to pass in view1. So let's go ahead and preview this. Let's hit refresh. Nothing's really updating on the screen here. We're just kind of working with the data in the background. I'm going to right click and go to inspect element. It logs all of the 16 different arrays. Because I created this int 8 array, it has logged all of them. And the first one, which is 0, has now been logged as 32. All the rest of them, because they've been created, are now 0. They're set to 0 by default. That's something to keep in mind and something important to remember there. So I can come in here, let me end this with a semicolon, but I can also come in here and say view brackets view1 and then say 2 and then update that with a number as well. But keep in mind that if I actually try to update this beyond that number, so int 8 only allows me to go up to 127. However, if I try to go up to, let's say 132 here, watch what happens. We're going to alert view1 again. I'm going to hit save and hit refresh and then go into inspect element. Now I'm going to go into here and then expand this out, and you'll notice it automatically jumps me back to negative 124. That is because we're trying to pass in a value that is not accepting. And so that's why you have to work with the correct data, making sure that you don't go beyond that. If you wanted to make sure that it goes beyond that, does some error checking, then you may want to use the clamped array instead of using int 8 array. So just a couple things to keep in mind there. Okay, so now let's actually change this. Instead of 8, we're going to change this to 16. And if I go ahead and save that and preview it, let's go ahead and right click and go into inspect elements. And you'll notice as soon as I alert this, I don't have as many to work with. Now the 16 bytes are actually being taken up by 2 because we're using this integer 16. Now we can also place a data view on top of this array as well that we can actually work with separate. So if I come in here, I can say let's view2 equal, and then I can do say new data view, and I can pass in that test buffer as well. So instead of defining the exact amount right here, I can create just a generic data view there. Now, as soon as I've created that generic data view, I can now set that data with certain types of values. So I can say view2 dot set, and I'm using a method called set int 8, and this will set the view to 8 here, and it'll allow me to pass in the value. I need to pass in two parameters. The first one is the position, and the second one is the amount that we want to actually update it with. So let's go ahead and do that. And so let's just go ahead and console.log, and we're going to go ahead and console.log view2. It's kind of a different way of doing it. Instead of defining the integer there, we're defining the integer as soon as we set it. So let's go ahead and hit refresh and then go to inspect element. And you can see that the first one is that int 16, and there's all of our different values here. The second one is just our data view, but if I expand that out, I can actually get to that data, and you can see that the byte length is set to 16 as well. But notice what's actually happening. When I set the second position to 43, it's actually updated that inside of the array inside of the buffer, because I'm working with the data. I'm not just working with the view, but that view is going through and actually passing in that data inside of here. So just keep that in mind, that I'm creating a new view, but I'm still working with that same array buffer data. So it's still updating that as well. A couple other things that I want to do here. Let's go ahead and actually just take that out here. And so we are going to just create a variable and say num equals view2 dot get int. We're going to go ahead and get the integer, and we're going to go ahead and get the position 2. Make sure we do get int 8, because that's the how we set it was integer 8 there. And I'm going to go ahead and log that as well. So we'll say console.log, and then we're going to go ahead and pass in num there. Now if I hit save and then preview, let's go ahead and inspect that. And you can see that we're actually getting an error. So let's double check this. Oh, looks like I spelled console wrong. So let's try this one more time. Hit preview, go ahead and go into inspect elements, and then let's preview that. And you can see that we're getting that number of 43. So I'm going into that position, and I am updating the value of 43, and then I'm getting that position, and I'm alerting that position here, or logging that position there. All right, so let's try something else here. What I want to do is actually create another view here. So let's say let's do this one as view 3. Then we're going to say new data view. Make sure that we have a space there, data view. And then we're going to pass in that test buffer. And let's go ahead and create another variable and store this data inside of num2. This is going to be our number 2. That is going to be equal to the view 3, get the integer 8. And we're going to say this is going to be 2 as well. Let's do console.log, and we're going to log num2. So even though I'm creating a new view, I'm still going to be able to access that data. So if I go ahead and right click here and go into inspect element, oh, forgot an equals sign there. So let's do equals, make sure we have semicolons there, and come back in here and hit refresh. Right click and go into inspect element, and you can see here that we're still getting that. So even though I'm actually creating a new view, I'm still working with that same type of base data. So we're going to do something a little bit different. We're actually going to go in and we're going to define how many numbers we actually want to work with inside of a certain view. So we have these 16 bytes, and so these 16 different positions here. And I'm going to go in here and I'm going to create a view. So let's go ahead and say view 4, and we're going to say equals, and then we're going to go ahead and say new data view. And we're going to pass in the data view and say this is going to work with the test buffer, but we're going to actually go in and we're going to start at position 7. So just like we've done here, we have this test buffer, but by adding a couple more parameters, we can say that we're going to start at position 7 and we're going to move over 3 positions. So inside of this view, I really only have 3 positions to work with now. So I'm only updating it from position 7 to the next 3 of those positions. And so now I can come in here and I can say view 4, and then I can say set int 8, and then we're going to go ahead and say we're going to set the position of 0, because we're only working with those 3 positions. So that first position, which is position 7, is now in this case the position of 0. So we're going to say 54, and then we're going to say view 4 dot set int 8 is we're going to update position 1. That is now going to be 23, and then we're going to go ahead and view 4 dot set int 8, and then we're going to update position 2, and that is now going to be 32. So now from here, let's go ahead and get those values, and we're going to alert those values. So I'm going to say let num alert equal, and then view4 dot get int 8, and then we're going to go ahead and get the integer 0, and then we're going to console.log, oh, forgot the E there, and then we're going to say num alerts. So let's go ahead and preview that. Right click, go into inspect elements, and you can see I get that 54. So even though I'm getting that 0 and I'm updating the 0, it's actually at that 7th position. So I'm still working with that same array buffer, and I'm still working with that same code. So that's how you start working with typed arrays. And when you start getting into other APIs, you may be working with these different types of arrays in different ways. And so I wanted to explore some of that inside of this video. In the next video, we're going to go ahead and wrap up everything that we've learned, talk about what we've learned in this section, as well as talk about what we've learned in this entire course. So let's wrap up this section by talking about what we've learned. We dove into an introduction to typed arrays, what it is, how it works, and how you can actually take advantage of it. We also talked about typed arrays versus standard arrays and the differences between those different arrays. We also talked about creating array buffers and what array buffers are, as well as being able to access typed arrays with views, how you can't actually access the data with buffers or anything like that. So that's really what you need to know to get started with typed arrays, and there's a lot more that you can dive in with typed arrays. This was designed mostly just to be an introduction to what typed arrays are and how to initially start working with typed arrays. That is what we have covered in this module. In the next video, let's quickly review what we've learned throughout the course and talk about some next steps. Let's quickly recap what we have learned in this course. We started out by talking about some more advanced methods that you can use when you're working with arrays. We then covered new collection types like sets and maps and how to work with each of those data collections. We then finally finished off with typed arrays and how to use typed arrays. You may be wondering, where do I go from here? Everything that we have learned about is great for working with data, but you may have noticed that every time I hit refresh in the browser, the data went away. A great next step would be to learn how to work with data that stays even after you hit refresh, like local storage or pulling data from a database. Sets, maps, and typed arrays are still useful when working with databases and local storage. So learning how to store the data in a database is a good next step for your progression. But I wanted to thank you for taking this course and making it all the way to the end. If you have any feedback on how I can improve this course, please don't hesitate